So our last section in chapter 7 is elasticity of demand. So chapter 3, section 7. Elasticity of demand, increasing the price of a product can impact the revenue to the seller. The increased price may result in sufficient decrease in the number of items sold to reduce the total revenue. On the other hand, an increase in price might lead to an increase in the revenue. Economists use the notion of elasticity of demand to study the relationship among price, demand, and revenue. So here's the idea. You're running a business and you're like, I have an amazing idea. If I raise the price, I'll make more money. Is that always going to work? What happens? If you raise the price too much, you're going to lose it. And reality, if you even raise it a little bit, you're going to lose people. The question is, if I raise it, how many people will I lose? What will happen? All that. I could raise it. I'll lose a few people, but still make money. That's a good idea. If I raise it a little bit, but I lose a lot of people, bad idea. So all this is tied to demand, price, how much people want something, and it really talks about the item. Like, for example, if you buy peas, I like green peas, right? If peas are normally $1 a can, and they go up to $1.25, people probably won't freak out, but they may. That 25 cents, they'll be like, I don't care about peas that much. I'm going to switch to corn. So I need to figure out, is my price sensitive at $1 or it's not sensitive, or I can raise it or not? Peas, you probably don't care about. You'll switch right away. But if you have these brand new sneakers that just came out and they're the best thing ever and they cost $200, if it was $205, would you change your mind? Probably not, if you really want those shoes. So sometimes it's sensitive, sometimes it's not, right? So that's what we're going to figure out. So the definition of relative percentage rates of change, the relative rate of change of a function is the derivative function over the original function. This is equivalent to taking the derivative of ln of f of x. Everything I'm about to show you is set up to get us to the equation. Once we get to the equation, we'll use the equation, we'll be fine. Again, this is setup. Okay? So the percentage rate of change of a function is 100 times the derivative function over the original function, which is the same as taking 100 times the derivative ln of the f of x. The alternative form of the relationship is called the logarithmic derivative. Stockbroker tells you about a stock where each share increased by 45,767 from December 2017 to December 2016 to 17. The amount of increase captured your attention enough to have you consider purchasing shares. So if someone told you that, hey, shares went up $45,000, you'd be like, heck yeah, I want $45,000. So she told you about a stock where each share increased by $59. And you're like, $59 is not that much. I like $45,000 over the same period. The amount of increase does not seem to capture your attention so much. Any comparison of these gains does not include the price per share of the stock for the calendar year 2007 omits a working basis for comparing. How do we compare these gains? Well, we need to first look at how much the stock costs. So if the stock went up $45,767, but each stock costs $249,719, now we're talking about something different. And if it went up $59.37, but each stock went up each stock was $113.30, now we can start comparing. $59 is always it's over half of 113, but the 45,000 is only a part of, not half of 249,000. So if we want to find just relative rate of change, we take the price change of one share divided by the price of one share, and we find out that, yeah, it went up 45,767, but each share cost 249,717, so that's only 0.183. But the one that went up $59.37, where it originally started 113.30, that's 0.524. So we actually find, looking at it, that the other stock, which wasn't really impressive, actually increased more. So an investor would purchase one share of the first stock for $249,711, would have gained $45,767. Had they have purchased $249,711 of the second stock, it would make $130,850. So although the dollar amount gains per share was substantially larger for the first stock, the relative rate of change was much higher for the second stock. So the idea is talking about not only do you have to look at the total amount, you got to look at how it's changing, okay? So the table gives the gross domestic product expressed in billions of $2005 and the U.S. population from 2000 to 2012. A model for the GDP is F of t equals 209.5 y plus 11,361, where t is the number of years since 2000. Find and graph the percentage rate of change of F of t. Note that the model and some of the tables, the GDP function is increasing. So again, this is all background. We're going to get to the formula soon. This is how the formula comes about. So remember we said the percentage rate of change is you take 100 times the derivative ln of your function, 209.5t plus 11,361. You work that out and you get 2,950 over the original function, 209.51 plus 11,361. We graph it, and the percentage rate of change is decreasing even though the GDP is increasing. So even though you're making more money, the rate at which you're making money is going down. So elasticity demand is used by economists to answer the question, when does an increase in price lead to an increase in revenue? So the definition, elasticity of demand. Let the price P and demand X. P is price, demand is X. Remember, demand is how much people want. For a product, be related by the price-demand equation of X equals F of P. The elasticity of demand at price P, denoted by EP, is EP negative relative rate of change of demand over relative rate of change of price. We're getting closer and closer to the formula. We're almost there. So EP equals negative relative rate of change of demand over relative rate of change of price. And then remember it came from the derivative with respect to price ln f of p over the derivative of price ln of p. We work that out. And here, finally, this is what we're going to start using. This is the formula I want you to write down. Okay? Everything behind is where we got up to. To find the elasticity of demand, which is how sensitive your price is, the elasticity, P stands for price, equals, okay? Negative. It always starts with negative. A nice way to remember that the formula always starts with negative, when you raise the price, what automatically happens? You lose people, okay? That's just a quick way to remember. Elasticity always starts with a negative, okay? It's kind of related, but it's a nice way to remember. Always starts with negative, okay? P, which is price, times the derivative of the function over the original function. This is what we're going to be using today. The slides before is where it comes about. And where it came from. Okay? So the price P and demand X for a product are related by the price and demand equation. X plus 500P equals 10,000. We want to find the elasticity of demand, EP, and interpret each of the following at 4, 16, 10. Now before I do this, hold on, we'll do it all together. I'm going to jump a little bit ahead, and I'm going to talk about what happened. So we'll work all this out a little bit. We'll work it all out a little bit. I want to jump here. Okay? So when you get a result, you're going to take a price, plug it in. That result is going to tell you if your price is sensitive, not sensitive, what you should do. When you plug in the price, your result is between 0 and 1. If your price is between 0 and 1, your demand is inelastic. If your result is between 0 and 1, then you are inelastic. In this case, demand is not sensitive to changes in price. That is, a percentage change in price produces a smaller percentage change in demand. Bottom line, if your result is between 0 and 1, right, then you can raise the price. Inelastic, you can raise the price. A price increase will increase revenue. Now, if your result is greater than 1, then you are elastic. If your price is greater than 1, you're elastic. That means demand is sensitive to changes in price. That is, a percentage change in price produces a larger percentage change in demand. Elastic, a price will decrease revenue. So if you're above 1, you're elastic. Don't raise the price. You should actually lower the price. So here's the big clue. If it's below 1, you're inelastic. Raise the price. If you're above 1, you're too high. You're elastic. Lower the price. So what's the special number? 1. Your job is to try to get your price and then plug in your price and your elasticity equal 1. That's called unit elasticity. If you're above 1, you're elastic, lower the price. If you're below 1, you're inelastic, raise the price. What you want to get E to equal is 1. If you can get E to equal 1, that means your percentage change in price produces the same percentage change in demand. So the idea is that you want your result to equal 1. If it's above 1, elastic, lower the price. Below 1, inelastic, raise the price. If you get 1, you pick the best price. And that's the name of the game. If you mess up price, you mess up everything. If you mess up price, you mess up everything. So let's back up. Now we can actually work on this problem. Okay, so take out a nice sheet of paper. And let's work it out. Now, in this example, they didn't give you x equals. So our first step is to get x equals. That's our first step. So they have x plus 5p equals 10,000. So our first step is to get x by itself. So how do I do that? Minus 5p, minus 5p. And then we can just keep it minus 5p plus 10,000. We'll keep it in front. Okay? So step 1, we have to set it up where we get x equals. Now, to find elasticity of demand, here's another formula that you need to know. To find elasticity of demand, EP, we take negative. It always starts with a negative. We take P for price times the derivative of the function over the original function. So to find elasticity of demand, it's negative P for price times the derivative of your function over the original function. Okay? And this is our function. X equals negative 5p plus 10,000. Okay? So we can actually call that f of p equals negative 5p plus 10,000. Okay? So we're going to go nice and slowly. We're going to find our elasticity of demand function, and then we're going to start plugging some numbers in. When we start plugging numbers in, we're going to interpret what that means. So, super slowly. To find your elasticity with respect to price, where does the formula begin? It begins with what? Negative. Don't forget that negative. If you don't have a negative, everything gets mixed up. Be careful. Are we okay? Then, P is simply P for price. So negative P for price, and then what's the next step? Derivative of your function. What's the derivative of negative 5p? Negative 5, and then the derivative of 10,000? 0. All of that over what? The original function. Stop there, take a second, make sure everything matches up and everything makes sense. Make sure everything matches up and everything makes sense. Now, just like always, algebra, we need to simplify. So what can I do to simplify? Negative times negative is positive 5p over negative 5p plus 10,000. So our elasticity function is 5p over negative 5p plus 10,000. Okay? I'm going to stop there. Make sure everybody saw how we got our elasticity function. Step 1, how we got our elasticity function. Are we okay? Now, your notes factored out of 5, and simplified it further. You can do that if you want. If you pull out the 5, then you're going to get p over negative p plus 2,000. Either one's fine. Either one's fine. One's a little more simplified than the other one, but can we all agree that they're the same? Can we all agree that it's the same? Factor out the 5, and that's what you get. Okay? But which one do you like better, the first or second? Doesn't matter. First one? Okay. So let's go to the calculator. Let's put this in Y1, and then we're going to plug numbers in. Be careful typing it in the calculator, because 5p divided by, what do we have to do this entire denominator? In parentheses. In parentheses. Without the parentheses, it will come out wrong. So when we go to the calculator, we go to Y1, we have 5x divided by negative 5x plus 10,000. That parenthesis does matter. Okay, make sure that's in Y1. Make sure that's in Y1. And then we're going to plug in these 4 prices. So let's say you're deciding what should I do for price. This will tell you if you're on the right path or not. Okay? So if you did this correctly, if you went to Y1, plugged it in correctly, go to the table, and then plug in 4. When you plug in 4, oh, wait a minute, I gave it the wrong. Hold on. I wrote down one thing wrong, which was this. This is supposed to be 500. 500. Does that change things? 500. 500. 500. It does change things a bit, doesn't it? Yeah, it changes all of them. Let's do it again. Let's do it one more time. And the reason why is just from the beginning, which will give us good practice. This is what we have. Okay? So let's start from here. Sorry about that. Let's start from here. That's X. This will be good practice for you. Find the elasticity of demand function. Let's use that last one as a practice. There's your X. There's your X. Plug into the formula to find your elasticity. There's your X. Plug in your formula to find the elasticity. We'll call that was practice. This is the real. So X equals 10,000 minus 500p. Plug into your elasticity of demand function, see what you get. And this is actually going to be really good for you because, number one, if you follow along, you think you know it, but do you really know it or you just copy? So this would be a good problem. And you can simplify or not simplify. All right, so we're going to go through this nice and slowly with the right function. It's negative p for p. The derivative is going to be what? Negative 500 over the original 10,000 minus 500p, which simplifies to 500p over 10,000 minus 500p. Again, you can simplify, but let's just stick with that. Does everybody see how to go from the equation to get our elasticity of demand function? Now, put that in y1. Sorry about that. Put that in y1. And then we're going to plug in 4 to start with. Make sure the denominator is in parentheses. Make sure the denominator is in parentheses. When you plug in 4 to the table, what should you get? 0.25. Now, I'm going to give you a quick answer, and then I'll give you a more in-depth answer. Okay? Did everybody get 0.25? Remember, this should be in parentheses, the denominator, when you type it in the calculator. When you go to the table and plug in 4, you should get 0.25. Okay? So quick answer, then long answer. Quick answer, our result is 0.25. That number is less than 1. Do you remember if that's called inelastic or elastic? Inelastic. And inelastic means it's okay to raise the price. Basically, $4 is too cheap. Charging $4 is too cheap. You can raise the price and it will be okay. Now, that's the quick answer. That's the quick answer. Okay? The longer answer, which I just want you to appreciate, the longer answer, which I want you to appreciate, is that means, let's look at the number where 0.25 came from. It came from 4 over 16. That means, for example, if the price, $4 price, changes by, that should be 16, 16%, the demand will be approximately 0.25. Okay? So bottom line, the top number, back up a little bit, is the relative change in demand over the relative change in price. So if I had 4 over 16, you would basically gain 16% of the price, you lose 4% of the demand. So that's a win. Okay? Let's do the same thing, but now let's plug in 16 and see what results you get. When you plug in 16 into the table, what result do you get? You get 4. 4 is greater than 1, which means at $16, you are elastic. What's your advice now? Lower the price. So again, quick answer, long answer. The quick answer is, you got 4, it's greater than 1, you're too high. Your price is too high, not good. You're elastic, so you should lower the price. So again, if it's under 1, inelastic, raise the price. If it's above 1, elastic, lower the price. What's the magic number? 1. And again, the longer answer. It comes from 16 over 4, top, bottom, top, bottom. That means if the $16 price changes by 10%, the demand will change by 4, 10%, 40%. So what's happening here is bottom number smaller than top number, you should raise the price. But if your top number is bigger than your bottom number, you should lower the price. That's actually what's happening. Okay? And then the last step, magically, what happens when you plug in 10? When you plug in 10, you get 1. That is unit elasticity. That is telling you the best price is how much? $10. Now, I do want to point something out. What I want to point out is we got lucky by finding $10. We got lucky by finding $10. Are you going to sit here and just pick numbers over and over and over and over again? But what number are we trying to achieve? 1. So I could have saved all this work and simply said, what's my elasticity? My elasticity is 500p over 10,000 minus 5p. And to find the best price, what do I want this to equal? 1. And I could have done what? Solve for p. So 1 is really 1 over 1. How do I solve this? Cross multiply. 500p times 1 is 500p. 10,000 minus 5p times 1 is 10,000 minus 5p. 500p, I did it again. 500p, thank you. And then how do you solve? Add 500p, add 500p. 1,000p equals 10,000. Divide by 1,000, divide by 1,000. The best price is $10. Okay? So elasticity of demand can also help you figure out the best price. You take your elasticity of demand function, set it equal to 1, find the best price. Good? First time you've seen it, we're going to practice, practice, practice. Okay? So what you should take out of this initial example is you're given the function, P is price, X is demand. You plug it into the formula for elasticity of demand, you now have your elasticity of demand function. If you plug a price into it and it's less than 1, it's inelastic, raise the price. If you plug in a price and it's greater than 1, you're elastic, lower the price. Your goal is to plug in a price and it equals 1, which we found out was $10, but that's just getting lucky. We can solve for the best price by taking your function set equal to 1 and solve and find the best price. Okay? There's your initial overview. Now, let's practice. Now we have all the setup and all the background. Here's what you're given. You are given the demand equals 1875 minus P squared. That's what you're given. Step 1, find the elasticity of demand function. After you've done that, then we're going to plug in P of 15, P of 25, and P of 40. Let's just start with that, and we'll take it from there. Step 1, find your elasticity of demand function. Then plug in 15, 25, and 40. Tell me is elastic, inelastic, or inelastic. Okay, let's double check to make sure our equation's correct. To find the elasticity of demand, it's negative P. The derivative will be what? Negative 2P, be careful with your signs, over the original function. Negative times negative is positive. You get 2P squared over 1875 minus P squared. So did we get the equation correct first? If we made a little mistake there, everything else is going to be wrong. You okay so far? Then we go to our calculator. We type in 2x squared divided by, make sure you put the entire bottom in parentheses. If you plug in 15, 25, and 40, are you getting the same answers? 15, 25, and 40, you should get 0.27, 25 gives you 1, and 40 gives you 1164. Are we okay? Questions there? Are we typing it in correctly, little mistakes? And then let's give it a little meaning. If it's less than 1, what is it called? Inelastic. Your goal should be to, you can raise the price. Then let's say you started at $15 and you got greedy and you went all the way up to 40. That's greater than 1. Now you are elastic, so you should lower the price. Your item is very sensitive at $40. It's not as sensitive at 15. And then when you plug in 25, you get 1. That's your best price. Are we okay? Now, I want you to get 25 on your own. How can you figure out 25? Not being handed to it, not being told to plug in 25. How can you solve for 25? How could you have found the best price right off the bat? What do? Set the equation equal to 1 and solve for P. And you already know it's 25, so that should help you with your algebra. How to solve that. Again, we already know it's supposed to be 25. So let's solve for 25. Again, we're realizing, do we have calculator issues? Do we have derivative issues? Do we have word algebra issues? That's the question. So 1 is really 1 over 1. So if we cross multiply, we get 2p squared equals 1875 minus p squared. You get that so far? Then what do I do? Add p squared, add p squared. That gives you 3p squared equals 1875. Now again, I'm going to stop a second. If this is all like, I have no idea what's going on right now, it's algebra, algebra, algebra. You've got to spend time on that. That's something we can't really stop and teach algebra again. You've got to know your algebra. What do I do next? Divide by 3, p squared equals 1875 divided by 3, which is 625. But do I want p squared or do I want p? P, so square root, square root. Technically, you get positive and negative, but the only answer that makes sense is 25. Positive 25. Are we okay? Now, I'm going to take this problem a little further. Because I want to make sure, number one, let's work on the basics. You're given price and demand. You get the elasticity of demand function. You plug in some prices. You know when it's an elastic. You know it's elastic. And at this point, you know how to find the best price. Are we okay? Let's dig a little deeper. So let's back up a bit, and let's give this some more meaning. Okay? What's something that costs $25? T-shirt. So we're selling T-shirts. P is price. F of P is demand. And this is the same equation, nothing new. But I'm going to give you a little context. We're selling T-shirts. P is price. F of P is demand. Let me explain what demand is. Demand is how many T-shirts. How many T-shirts will people want at a certain price? How many T-shirts will people want at a certain price? So if this was an old problem, you could have taken the derivative, set equal to 0, and all this other stuff, or you could try to find the maximum. You could do all these different things. But right now, you're selling T-shirts. P is price. F of P is demand. Demand is how many T-shirts at that price. Okay? So what you did was, just to kind of recap, you found your elasticity of demand function to be 2p squared over 1875 minus p squared. You set it equal to 1. Solved, and you found p equals 25. That's the best price. Are we okay? Any questions so far? I'm going to ask 2 more questions. Question number 1. We know the best price now. How many T-shirts will be demanded at the best price of $25? So if I know the best price now is $25, now you're able to tell me how many shirts will I sell. Figure that out. We have all the pieces there. If you know that the best price is $25, I want to know how many T-shirts will be demanded at $25. So, will I plug the 25 into the elasticity of demand? No. Where will I plug that 25? Into the original, because I now know the best price. And when I plug 25 into the original, what do you get? What do you get? 1250. 1250 what? T-shirts. So, once you find the best price, I can then ask you, how many T-shirts will people want? The last question. You know that the best price is $25, and you know the demand is 1,250 t-shirts. The last question is, how much revenue will you make? So if I know that the best price to charge is $25, and I know that I'm going to sell 1,250 t-shirts, I can then figure out my revenue. So if you want to find revenue, what do you do? What do you do? 25 times 1250. Each one is $25. You're going to sell 1,250 shirts. How much revenue will you make? 31,250. Okay? So again, you have to take this a step further, because what does this mean? I can give you a function, find the other function, plug into the function. That's not understanding. That's not meaning. What we're just found out to do is that you tell me how much people want it. I got it. Demand function. With that, I can plug into elasticity demand. I can find the best price. Now I know the best price. Now I know how much is demanded. Now I know how much money I'll make. See how that's all connected? That would be a typical elasticity demand problem. Okay? Plug into the pieces, but to get all the pieces, you have to know what it means. So to finish up this chapter, make sure we write this down. If demand is inelastic, consumers tend to continue to buy even if there's a price increase. In this case, a price increase will increase revenue, and a price decrease will decrease revenue. So remember we said if it's inelastic, raise the price. If demand is elastic, consumers tend to reduce their purchase if there's a price increase. So we say if it's elastic, reduce the price. A price increase will decrease revenue, and a price decrease will increase revenue. Elasticity differs for different products. When there are close substitutes for product, or if a product is a luxury rather than necessity, the demand tends to be elastic. Jewels, furs, furniture tends to have high elasticities, and larger price increases tend to decrease demand, while large discounts in the price tend to increase demand. So it's all using these ideas, are you elastic or inelastic, if you can play with the price or not. On the other hand, when there are no close substitutes, or the price is a necessity, the demand tends to be inelastic. Milk, eggs, sugar, light bulbs, some examples of products with low elasticity. And that ends chapter 3. Okay.